All right, last three examples here. This is a little different because they're polyatomic ions. They have a charge, and this is where you got to factor in the charge. So nitrogen, there's only one of them. There's 4 hydrogens. Nitrogen is in group 15, so it's going to have 5 valence. Little hydrogen always has 1. So 1 times 5 is 5. 4 times 1 is 4. Add them together and you get 9. 9 is an odd number. Anytime you see an odd, not even, an odd number, you know something's wrong. And what's wrong is that we didn't yet factor in the charge. This is ammonium. Ammonium makes a +1 charge. +1 means it's going to lose one of those negative electrons. It's going to kick it out. So our 9 is going to go down to 8 because you lose one of them. So we have 9, kick out one of those negative things. So you have one less negative, and now we go down to 8. So if you look at which of these pictures is correct, well, hydrogens have to have just a single bond, so right away this is wrong. These guys down here, that's wrong because hydrogen has more than just a single bond. So it could be B or D. Hydrogen has single bonds. Now we have to focus on the center atom. This center atom, nitrogen, has too many. It's got 2, 4, 6, 8, and then see that little dot? That's wrong. This is correct. Nitrogen has 2, 4, 6, 8. Remember, it's either 2 for hydrogen or 8 for every other element. So everybody's good here. And what does our grand total add up to? 8. Not 9. That's wrong. If you have that 9th electron and you try to put it on the center atom, it's wrong. It's going to give the center atom more than an octet. If you try to put it in the outer atoms, it's going to also make it wrong because hydrogen can't have 3 electrons. It only needs 2, a single bond. So B is big time wrong. Correct answer, D. There's 8 total electrons, and everybody gets their version of the octet. All the hydrogens are on the outside, and nitrogen on the inside gets its 8. So we're good. NO3, this is nitrate, and nitrate makes a -1 charge. So nitrogen, we already figured out there's one of them in the formula, but it has 5 valence. We can just copy from above. 1 times 5 is 5. Oxygen, there's 3 of them. And if you look on the periodic table, oxygen's over here in group 16, so it's going to have 6. You're going to start to remember some of these because you use them a lot. 3 times 6 is 18. If you add that up, you come out to 23. That's wrong. So we have to factor in the charge. A -1 means it's gained 1 more negative electron. So instead of 23, gain 1 more. Make it 24. So now let's figure out who's right and who's wrong. This one, A. That looks like it's got 8, 8, 8, and then check our center atom. Wrong, because it has 2, 4, 6. So it can't be A. Oops, our center atom does not have an octet. So A is wrong. C looks absurd. Look at our center atom. Right away, you know that that's way too many. That's wrong. B. B looks pretty good. There's 8 there, 4 and 4. This one has an octet. This one has an octet. And look at the center atom. There's a double bond and a single and single. 4 plus another 2 and another 2. That's 8. So everything looks good for B. It might be B. We'll put a little check there. And then look at this last one. That is 8. That's 8. That's 8. This center atom has 8. It's got 6 in the shared bonds and then 2 of its unshared. So that's 8. So D's looking pretty good too. So B or D, which one is it? we got to make a final decision. We've got to figure out which one has 24 electrons. So let's look at this last one that we just counted. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. That does not match. So it can't be D. And just to verify, let's check B. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So B has 24. That looks good because it matches. So it is in fact B. There's 24 electrons, yet that oxygen got 8, the nitrogen in the center got 8, the oxygen on the right got 8, and the oxygen on the bottom got 8. They shared 24 so that each of these 4 atoms got 8. We didn't have 32 electrons. We were able to do it with only 24. And finally, PO4 with a -3 charge. This is phosphate. Phosphorus, there's only one of them. No number there. There's 5 valence. How do I know? I checked my periodic table. I couldn't imagine doing this without a periodic table unless you memorize this all. Phosphorus is in group 15. So you put a 5 there. 1 times 5 is 5. Oxygen, there's 4 of them. And oxygen has 6 valence. We've looked at oxygen quite a bit. You're going to start to remember that oxygen is always in group 16, so it's always going to have 6 valence. And that hopefully will start sticking in your head, that it has 6. So 4 times 6 is 24. Add them up. 5 plus 24 is 29. That looks to me like it's an odd number. That doesn't quite work. We forgot about the charge. -3 means it gained 3 more of these negative things. So if you gain 3 negatives, you go from 29, 30, 31, 32, up to 32. And I said that 32 is going to be the highest you can go. So they've got to divvy up 32 electrons. We got to find out which picture has everybody with an octet and uses 32 electrons. Right away, A, wrong. Why? Because each one of these oxygens has 2 electrons, not 8. It needs 8. It only has 2. So it's big time wrong. C, each one of these oxygens is wrong because it has 2, 4, 6. It only has 6, not 8. Wrong. Plus, look at the crazy phosphorus in the middle. The crazy phosphorus in the middle has double bonds all around. 2, 4, 6, 8, 10, 12, 14, 16. That's wrong. Big time. B, this oxygen has 8. This one has 8. This one has 8. This one has 8. 6 unshared plus 2 shared. All the oxygens look great. And look at the center atom. All those single bonds. 2, 4, 6, 8. Everybody's got 8. B looks great. And how about D? 2, 4, 6, 8, 10. That first oxygen we looked at has 10. That's wrong. The only one left standing is B. B is correct. If we look at the situation, we already know that each one of those atoms has 8. There's single bonds all around. That's all great. And what do they use? 32 electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So just verify. Don't be lazy. You can skip count up to 32. It doesn't take very long. But verify that your answer is correct. Make sure that your number of electrons matches and that everybody has an octet. It's as simple as that.